In this video, we're going to be talking about how to simplify algebraic expressions. So when we're working with this idea, there's a couple of key things that need to be followed and understood before you actually get into any questions involving this. The first is when you're dealing with like terms, what a like term is they have the exact same pronumeral factors, including powers. So what that means is letters. Pronumeral means letters. And we'll look at this a bit later, but X, A, C, any letter that can be used in maths, that is a pronumeral. And when it says including factors, that means that, say, if we have something like X and X squared, they're not like terms because they may be the same letter, but they don't have the same power. So that's important as well. When we're adding and subtracting, that applies to like terms only. So you can only add and subtract if they have the same letter or they have the same letter with the same power. But when we're multiplying and dividing, that applies to all terms. So we're going to look at how these three things work. So the first example is just identifying like terms. So the question asks, write down the like terms in the following lists. So what I'm going to do, I've got a red pen here. I'm going to underline what's similar. So we've got 3x, 6a, ax, a, and xa. Okay, so we can see that there's an x here, but there's no other x by itself. So it's the only one like it. So it doesn't have a like term amongst this list. We do, however, have 6a and 3a. They both have an a, so that works. The only other situation we have is ax and xa. They're like terms as well. And the reason why is because just because the arrangement is different doesn't mean that the letters aren't the same. They're exactly the same. So we can just count that as like terms. So for our answer for A, the like terms are 6a and 3a and 2ax and 5xa. There are like terms for part A. Next, for part B, we'll do the same. The first one has ax. We'll look through the rest and see if there's another ax. There isn't, so that's the only one that has the same like terms as ax. Now you may notice that I skipped over the fact that these are both xa and xa, but the x is squared and this x isn't, so it doesn't help us in this situation. However, we've got our x squared a, and then there's another x squared a. So I'm going to underline those to say that they're the same. We're left with 3a, which is the only one with an a, and we've got 3x, it's the only one with just an x. So our only like terms for B are 3x squared a and minus 5x squared a. Moving on to our next example, we're going to be collecting like terms. So what that means is we're adding and subtracting like terms. Remember, we said at the beginning, when we add and subtract, it only applies to like terms. Okay, so when we're simplifying the following, we'll start off with a. I'm going to do the same thing that I did over here. I'm going to underline the like terms. So we've got a 4a, 5a, and a 3. Well, 4a and 5a, they're both just an a, so they're like terms. And then we've got a 3 with no letter, so that's its own like term. So we've got only two things going on here. Now, when we're adding like terms, we've got a and a. We just add the numbers like normal. We've got 4 plus 5. So that's going to be 9a, because the a counts as well. And then we've just got a 3 left over. So our answer for A is 9a plus 3. We can't add them anymore because they are not like terms. And all that matters is that they're like terms when you're adding and subtracting. We'll move along to B now. We've got 3x plus 2y plus 5x minus 3y. We've got some x's and y's, so I'm going to underline the x's first. Notice I'm underlining the positive that goes with this 5x. That's because that positive matters. You'll see why in the next part here, we've got a positive 2y and a negative 3y. Most common mistake is people will add 2 and 3, but really it's 2 take away 3, and that's really important. It's the difference of getting it right and getting it wrong. So for B, we've got 3x plus 5x, which is going to be 8x, and 2y minus 3y. Well, 2 minus 3 is negative 1, so it's negative 1y, but we can rewrite that because the 1, it kind of counts already, so we're just going to have 8x minus y, and that's our answer for B. We can't combine the x and y's because we're just adding and subtracting. For C, we've got 5xy plus 2xy squared minus 2xy plus xy squared. Okay, so we've got an xy here and an xy here. Notice the question, it looks a bit tricky because some are squared and some are not. We'll just deal with the ones that are not first. We've got 5xy minus 2xy, and we've got plus 2xy squared and plus xy squared. They both have xy squared in that order, so we can just deal with them as like terms. First of all, we've got 5xy minus 2xy. That's 3xy. Then we've got plus 2xy squared plus xy squared. Remember, there's an imaginary 1 there. So we've got 2xy squared plus 1xy squared. That's 3xy squared. And that's our final answer. Okay. Next example, we've got multiplying algebraic terms. So when we're multiplying, it applies to all terms. So first of all, it says simplifying the following. For A, we've got 2a times 7d. Well, because we're multiplying and it applies to all terms, we don't have to worry about like terms in this situation. First of all, let's multiply the numbers. 2 times 7, that's going to be 14. Then there's an a times d. We can just write that as a d. And that's the answer for A. For B, we've got minus 3m times 8mn. So we'll times the numbers first. We've got minus 3 times 8. So there's a negative times a positive. That's going to be a negative. And 3 times 8 is 24. Then we've got m times n. Okay, I'm just going to write it in the same way we did here, but we can go a bit further. So we've got 2 m's and an n. Now a way we can write that a bit simpler is if we've got 2 of the same letter and we're multiplying it, or more than 2, we can simplify it like this. Minus 24, that stays the same. It's going to be m squared n, because there's 2 m's being multiplied, so we can write m squared and then there's an n left over. So that's our final answer. Most of the time you can go straight from this to this, but if it's easier for you, you can go here first and then to here. Okay, our final example is dividing algebraic terms. Now before we said when you're multiplying and dividing, it applies to all the terms. So keep that in mind whilst we're answering this question. So we're simplifying the following again. A says 18x over 6. So I'm going to first of all start by rewriting this, just so I've got some room to work with it. Now notice there's an x on the top, there's no x on the bottom. That means our final answer for this will have an x at the top of a fraction. Now what goes on top and the bottom with the numbers, you need to find a common number that can be divided by 18 and 6 to try and simplify. Sometimes that doesn't happen, but in some cases it will. And more often than not, when the person is asking a question, it can be. So a quick way of doing this is to just type it in the calculator, ignoring the letters. So we've got 18 over 6. That's going to be 3. So that when we're writing that as a fraction, that's going to be 3 up the top and 1 on the bottom, because we know that 3 divided by 1 is also 3. So that's why it's that way. But we can simplify it again by getting rid of the 1 and just writing it as 3x, because these are equal. Now, if you want to actually understand why does that 18 on 6 become a 3 over 1, let's have a look at it a bit closer. I'm going to change to black for this. So how many times does something go into 18 and something go into 6? What's a common factor? So if we list the factors of 18 and 6, we've got we'll start off with 6, it's a bit easier. So the factors of 6, we've got 1 and 6, and 2 and 3. So they're our factors for 6. For 18, we've got 1 and 18. We've got 2 and 9. We have 3 and 6. Okay. Now we'll notice that at the very least there's a common 6. So that's, in this case, it's the highest common factor between 6 and 18. It's the largest number that they both have in common. So as that's the case, if we divide 18 by 6, 18 divided by 6, we get 3. So I can replace it with 3. And 6 divided by 6 is 1, so I can replace it with 1. So that's how we get from here to here. But in most situations, you can use the calculator and see if that helps you, but this is good practice to use this method. You'll see why when we're working with letters more specifically. Okay, so you can see here there's a lot more letters going on with B, so we'll answer that one. First step, when you've got a division like this whole thing here can be put on the top of a fraction, and this whole thing here can be put on the bottom. Okay, and that always works because a fraction and division, they're actually the same. So if I rewrite that, we're going to have 12a squared b all over 8ab. Now, we're going to deal with the letters first. Now, we first look at what letters are in common. So we've got A's on the top, A's on the bottom, and B's on the top, B's on the bottom. Now, if we go back to that last example, you remember that we had m squared is the same as 2m's being multiplied together. So this is 2a's being multiplied. That means that we've got 2 a's on the top and 1 a on the bottom. So I can cancel that single a. So we'll have no a's on the bottom, and we'll have 1 a on the top. We've got 1b here and 1b here, so we can cancel those b's, and we'll be left with just on the top here, just an a on the top of a fraction. And that's all the letters done. What's left is the numbers. We've got 12 over 8, so that's 3 over 2. So I'll write the 3 on the top and 2 on the bottom, so our answer is 3a over 2. Now, once again, you can list the factors of 12 and 8, or you can just try some. For instance, 12, we can see, oh, well, there's 12 and 8, they're both even, so we could do 12 divided by 2 gives us 6, and 8 divided by 2 gives us 4. So we can rewrite it as 6a over 4. Now you can see that's not the same answer as 3a over 2, and that's because if you notice 6 and 4, they're both even, so we can do it again. So if we divide 6 by 2, we get 3. If we divide 4 by 2, we get 2. So that means our final answer will be 3a over 2. So you can see there's the two methods you can use to find the division of algebraic terms.